mid-latitude cyclones. These are just systems of low pressure, but they're large systems of low pressure, over 1,000 kilometers across. Now they usually go from west to east. This is, follow the westerlies, right? West to east. And they always have this warm front. Where's my mouse? There we go. We always have this warm front, and it's followed by a cold front. Now we do know what's going to happen because cold fronts move faster than warm fronts, right? So you can kind of figure out what's going to happen here. But as you can see, they produce a lot of precipitation. Why? Well, this low is going to produce a lot of precipitation. This warm front is going to produce a lot of precipitation, right? Rain over a large area. And the cold front is going to produce a lot of precipitation, thunderstorms over a smaller area, right? For shorter time. These cyclones also turn. Now, because we're going to talk about mid-latitude cyclones in the northern hemisphere, we're going to say they turn counterclockwise. Kind of an interesting history about how these cyclones didn't really come about because they've always been there, but how the model for them or how the theory of them came about. It actually came about in World War I. By Norwegians. So we used to call it the Norwegian cyclone model. And there's the 4 Norwegians that figured it all out. We have later changed this to the polar front theory. Alright, why? Because, well, it starts with the polar fronts. Now remember the Rossby waves are coming down with the jet stream. Right, the CP is fighting with the MT. That's kind of what is happening here. The polar front comes down, and it starts to develop this mid-latitude cyclone. And what happens is cold air collides with warm air. Okay, so let's go through one, right? So the life cycle, the first part, the developing and the strengthening, is called cyclogenesis. Right, so the beginning of the cyclone, cyclogenesis. Now, midlife crisis, yeah. Mid-latitude cyclones can last days to weeks. And what's interesting is there's 200 of them a year in the northern hemisphere. 200. Right? We think if we get 24 hurricanes, that's a busy season. There's 200 of these a year. Alright, so how these things start? The clash of two air masses. What's that called? A stationary front. Right, so it starts with a stationary front. See why we had to kind of back up and learn about fronts before we could continue? Now, in the stationary front, a little wave develops. You can kind of see it down here. A little wave develops in this. And so you're stationary, something is starting to move. It's not completely stationary. And as that wave strengthens, you end up separating the warm air from the cold air. And so you can see that down in this one here. The warm air is starting to change from the cold air. Now, what happens? The warm air moves poleward, right? Because you're thinking MT kind of air. What's MT going to do? It's going to move up, right? So you've got the warm air moving up. And of course, because we're rotating, you can't just move straight up. You have to kind of go with the westerlies. So off you go, right? You're moving up and out. And the cold air also starts to move. But it starts to move down and out towards the equator. So this is going this way, this is going this way. So the cold air is essentially chasing the warm air. You know what's going to happen, right? Right at where that stationary front separated into two air masses, that's where you get a low, right? So you have a low area of pressure, you have your warm front, you have your cold front. Now, your pressure around the low starts to drop. Uh-oh, what does that mean? That means that it gets worse, right? And the winds start to get stronger because when a low happens, everything wants to go to the low. Everything, if you remember way back when, everything goes from high to low. So if your low strengthens, like your low drops, your winds are going to start to flow in faster. If your winds start to flow in faster, your cold starts to pick up. Your cold starts to pick up. Eventually, it meets the warm front, and you get your occluded front. Your occluded front is the beginning of the end. Once the occluded front happens, it's basically killing all of the juice that the storm is having to. You know what I mean. Anyway, so it's the beginning of the end, and it continues to take over until finally you just get all occluded and it goes away. So this is what it actually looks like. Some people call these the number 9 storms. I've heard people refer to that. So if you've taken a different earth science class and they say number 9 storm, they're talking about the mid-latitude cyclone. Or some people call it the comma, because it looks like a comma, right? There's comma, comma tail. Right? And then this dry slot right in there. So again, you can kind of see why Florida kind of gets the tail end of everything. Alright, so what is it like to live underneath a mid-latitude cyclone? Depends where you are. Okay, if you're up where I grew up, which would be about here, it's miserable. Because I'm just south of this GF line. So let's pretend I'm on this GF line. Right? GF. So what's going to happen is you've got an area of low pressure. Yay, that means bad weather, right? And at the same time you have the warm front coming in, and so that means what? Bad weather. Okay, and okay, so on the GF, bad weather, and you're like, okay, but at least it's a warm front coming in, so I'm going to have warm air, right? No, because you've got the cold right next to it, right? So you don't get anything. You just get rain, 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 cold air. Not pleasant. I can tell you from personal experience, not pleasant. Down here, you get, your regular day, and then your warm front comes through, and so you get your clouds and your rain over a period of time, right? Gentle slope, lots of rain over a large area over a long time, right? But then you get this beach day. I mean, the warm air comes in, you're like, woohoo, it's all nice and warm, let's go for a walk, let's play soccer, let's fly a kite, let's go to the beach, I don't know, whatever you do on a warm day, right? I'm sure your answer is, let's study meteorology. That would be the correct answer, but usually that's not the answer I get. Anyway, off you go. So with this, you enjoy this, but then suddenly you get thunderstorms, right? Thunderstorms. Fast storms move through quickly. And what's after that? Oh, the cold air. Right, so no more beach day, perfect day for studying meteorology.